Hello students, welcome to Boundless Maths, your trusted space for both maths and science. In today's video, we are going to cover the chapter Acid, Bases and Salts from Class 10 CBSE Science curriculum. In order to score well in any subject, you need to follow a basic three-step process. Number 1, understand the content. Number 2, learn the content without missing on important details using structured notes. And number 3, practice as many questions as you can as per the format of the paper you are going to appear for. So in today's video, we are going to cover the chapter Acid, Bases, Salts from Class 10 CBSE Science Notes authored by me, specifically designed to make the NCERT content concise, easy to learn and remember. So it is like a companion for your Class 10 Science NCERT textbook. If you want a copy of these science notes, you can visit my website www.boundlessmaths.com. So without much delay, let's get started. So the basic question is, what are acids and what are bases? Acids are the substances that release H plus ions in water, and bases are the substances that release OH minus hydroxide ions in water. You must have read about all this in low grades also, right? So acids, they turn blue litmus red, whereas bases turn red litmus blue. Acids are sour in taste and bases are bitter in taste. B for base, B for bitter and B for blue. So it is turning red to blue. So that's how you can remember base, blue, bitter. Examples of acids are hydrochloric acid, sulfuric acid. Examples of bases are sodium hydroxide. Now the water soluble bases, they are also known as alkalis. These are the differences between acids and bases. Now what are the similarities between the two? Are they similar also in some respect? Yes, they are similar. Both acids and bases, they react with water and they produce ions in water. They disintegrate into ions. Both acids and bases release hydrogen gas on reacting with metals and carbon dioxide gas on reacting with carbonates and bicarbonates. Both acids and bases, they act as electrolytes. So they are good conductors of electricity. And both of them change the color of the litmus paper, right? So when they are conducting or when they are acting as electrolytes, acids release H plus ions in water, whereas bases release OH minus ions in water. Now there are certain substances that can be used to find out whether a given substance is acidic or basic in nature. These are called indicators. There are three types of indicators: natural indicators, synthetic indicators and olfactory indicators. So natural and synthetic indicators, they indicate the nature of the substance by changing color, whereas olfactory indicators change their odor or the smell. The smell of these substances changes because these indicators have a characteristic smell which either remains same or it disappears on reacting with an acid or a base. So the natural indicators are obtained from natural resources from plants and animals. So examples are litmus. It is a purple color dye extracted from lichen plant. L for litmus, L for lichen. Next is turmeric. Another one is red cabbage juice. So all these are natural indicators. Synthetic indicators are prepared in labs using chemicals. Examples are phenolphthalein and methyl orange. And olfactory indicators are clove oil, onion, vanilla essence. As you know, all these three, they have a characteristic smell which disappears. So let's have a look at how acids and bases show change in color or change in smell with these indicators. The first one is red litmus. Acids do not show any change with red litmus, but bases change red litmus to blue. Blue for base, B for blue and B for base. Blue litmus. Acids change blue litmus to red, whereas there is no change in case of a base on blue litmus. Turmeric is originally yellow in color. It does not show any change in color with acids. However, it turns reddish brown on reacting with bases. Now you must have seen certain stains on your clothes, turmeric stains on your clothes, and when you wash them, they turn reddish brown on applying soap. That means the nature of soap is basic. Next is red cabbage juice. Originally it is purple in color. Acids change this purple color to reddish color and bases change it to greenish yellow. Phenolphthalein is a colorless indicator which does not show any change with acids, but it turns pink when used with a base. Next, methyl orange is originally orange in color. Again it changes to red with an acid. However, it changes to yellow with a base. Now these three olfactory indicators, onion, vanilla essence and clove oil, they do not show any change with acids. However, their smell vanishes when used with bases. Now how do you learn this table? It is very important that you learn the change in colors shown here in this table, because the question would start a substance X changes to pink with phenolphthalein. Identify X, and then the further might ask you to do certain other things also. So in such questions you need to understand and you need to learn these color changes. How do you learn that now? Acids, if you look at the column for acids, either there is no change, or whenever there is a change it is turning into red. So if you have a question saying something like a change in color of yellow, so that means it has to be a base. So all the other colors are in the column for base. Reddish brown, greenish yellow, pink, yellow. So all these colors are with bases. But acids only show red or reddish color change. Otherwise there is no change. So if the question says the substance X with turmeric shows a reddish brown color, that means X is a base. So just learn this table nicely. It is very important that you learn this table with the color changes to help you attempt the questions. Now let's come to classification of acids. Now there are the different types of acids classified into different categories. The first one is organic and mineral acids. Organic acids, as the name tells you, they are obtained from plants and animals. For example, citric acid from citrus fruits. Lemon, orange, all these fruits have citric acid. Lactic acid in curd. Mineral acids are inorganic acids, for example again sulfuric acid, hydrochloric acid, nitric acid, any of the acids, they are all prepared in labs, they are all mineral acids. Dilute and concentrated acids. Now in dilute acids, the concentration of H plus ions or the concentration of acid is less in aqueous solution. Whereas in concentrated acids, the concentration of the acid is more. Next is weak acids and strong acids. Now weak acids have a higher pH as compared to strong acids. So they produce less H plus ions in water. They are weaker. They do not get disintegrated 100%. So they do get disintegrated in water, but not to that extent the way strong acids behave in water. So strong acids, they have a very low pH around 0 and they produce more H plus ions in water. Examples are citric acid, acetic acid, and examples of strong acids are sulfuric acid and hydrochloric acid. Now organic acids are generally weak acids, but don't mix both of them. Weak acids and organic acids is not the same. There are certain organic acids which are strong and there are certain mineral acids which are weak. So don't mix organic acids with weak acids and mineral acids with strong acids. Weak acids and strong acids are different, organic and mineral acids are different. So don't make this mistake, right? Now how do you understand or how do you find the strength of an acid or a basic solution? For this we have a pH scale. This scale is used to measure the concentration of ions in a solution. pH, P stands for potence. It is a German word which means power. 7, pH of 7 means it is neutral. Acidic means less than 7 and basic is more than 7. So if any substance is acidic, it will have a pH less than 7 and basic substances will have a pH more than 7. Now if you look at this pH scale, gastric juice has a pH of 1.2. Why? Because gastric juices release hydrochloric acid that makes the medium of the stomach acidic. This you have already covered in life processes, so you can watch the video on life processes for details on how the stomach works. So this pH is needed for pepsin to break down proteins. Next, lemon juice has a pH of 2.2. Pure water or blood has a pH of 7.4. Milk of magnesia has a pH of 10 and NaOH solution is a very strong base having a pH of 14. Now as you move in this pH scale, this is 7 is neutral, and when you go up till 14, the concentration of hydroxide ions keeps on increasing, and if you go towards 0, the concentration of H plus ions keeps on increasing and it becomes maximum around pH of 0. So that means acids, they release H plus ions and bases release OH minus ions. Now if you have an aqueous solution of an acid and a base, acid or a base in water, that does not mean that it will have only H plus ions or only OH minus ions. So there will always be some concentration of OH minus and H plus both existing together. For bases, the concentration of OH minus ions will be very high, whereas the concentration of H plus ions will be very low here. And for acids, the concentration of H plus ions will be very high, whereas the concentration of OH minus will be very low. These ions get created from water also to some extent. So in any case, from 0 to 14, whatever is the pH of the substance, the solution, aqueous solution will have both OH minus and H plus ions. Always remember this. This can somewhere be there, asked in an assertion reason question. Now, what is the importance of pH? Why do we need to understand the pH and understand the impact, how it is impacting our human body? So, ideal pH for human body is 7 to 7.8. In fact, for all living organisms, it is somewhere around 7 only. Stomach produces HCl that brings down the pH to 2, which is needed for pepsin to work. Antacids like magnesium hydroxide, milk of magnesia, it is one of the major components of antacids. It is used to neutralize excess acid in the stomach, right? Now, tooth decay. If we have some leftover food in our teeth and we sleep like that without brushing, even though your mother reminds you to brush your teeth, but still you slept like that. So what is going to happen is overnight the bacteria present in your mouth, they start breaking down those food particles and they release certain acids in this process. Now the acids released by these bacteria brings down the pH of the mouth to less than 5.6 or 5.5. So in your answer, if you get the question on tooth decay, you have to specify that the pH of the mouth gets below 5.5, and that's why the enamel of the teeth gets corroded and it gets impacted and leads to cavities by the action of bacteria. So you have to specify this pH less than 5.5, it's very important. So that's why it is always advisable to clean your teeth with toothpaste before you go to bed, because toothpaste is basic in nature and it neutralizes any kind of acidic content in your mouth. Next important point to note here is tooth enamel is made up of calcium hydroxyapatite. This is crystalline form of calcium phosphate. This might be asked in a MCQ. So just remember this. Now the atmosphere of planet Venus is made up of thick white and yellowish clouds of sulfuric acid. Again important for a 1-marker question. Next is the plants and animals, they also need certain specific pH for their survival. Now what is acidic rain? You know, there are certain non-metallic oxides that are present in the air around us, something like CO2, SO2, NO2, all these are suspended in the air. And when it rains, these non-metallic oxides, they get washed off with water, they react with water to form acids that are the cause of acid rain. So that is called acid rain. It's not the acid is raining, but these oxides, they react with water to form acids that are causing that acid rain. So acid rain brings down the pH of soil to less than 5.6, which impacts the aquatic life. Now for humans, because we need around 7 to 7.8, even for other living organisms, the pH needed is 7 to 7.8. So when the pH goes down 5.6, it starts impacting the aquatic life. Now soil. Soil can be acidic also, alkaline also. Why acidic? Because of acid rain. So how do we make it come to the ideal pH so that crops can grow properly? You treat the soil with quicklime or slaked lime. These two are basic in nature. So they neutralize the amount of acid present in the soil and hence make it fit for growing crops. If the soil is alkaline, maybe because of overuse of fertilizers, then you need to add decaying organic matter, because again decaying organic matter is going to release certain acids due to the action of bacteria and it will neutralize the alkaline soil and make it neutral so that the crops can be grown easily. Now this is very important, bee sting and wasp sting. What is the difference between them? Bee sting leaves methanoic acid in our skin which causes pain and irritation. So this can be neutralized by a mild base like baking soda. So if anyone gets a sting by a bee, you can quickly go to your kitchen, take out baking soda, make a paste of it and apply on it. So it will make you feel better. Because bee sting leaves methanoic acid and this acid gets neutralized by baking soda. Next is wasp sting. Now this is not acidic, it is alkaline. So it is neutralized by a mild acid like vinegar. Obviously you cannot use a strong acid here, right? Otherwise you will burn yourself. So you need to use a mild acid like vinegar to neutralize the impact of wasp sting. And the third is nettle leaf sting. Nettle is a plant and it has stingy leaves. So if you get pricked by a leaf of nettle, it can be neutralized by dock plant which grows besides the nettle plant only. So because nettle plant leaf also leaves methanoic acid in the skin, which can be neutralized by the dock plant. Now here are some very commonly used formulas that you should remember before we move forward. Pause this video, learn the formulas for these acids, bases and compounds that are given here, because these are very important and they are all needed for the reactions that we are going to learn in this chapter. So the first one is hydrochloric acid, it is HCl. Next is sulfuric acid, H2SO4. Next, nitric acid, HNO3. Even though most of the reactions would involve any of these three acids, but you should also know acetic acid, CH3COOH, because it is also used in some of the cases. These are the acids. Now what are the bases? Sodium hydroxide, potassium hydroxide, magnesium hydroxide, ammonium hydroxide. Sodium hydroxide is NaOH, sodium is Na. Potassium hydroxide, KOH, magnesium hydroxide, MgOH twice, ammonium hydroxide, NH4OH. So these are the bases that are normally used in the reactions that we are going to study in this chapter. And the last formula that you should remember is for bleaching powder, which is CaOCl2, because this is one of the very basic formulas that many children make mistakes with. So just pause this video and learn all these formula. I'll just repeat: hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3, acetic acid, CH3COH, sodium hydroxide, NaOH, potassium hydroxide, KOH, magnesium hydroxide, MgOH twice, ammonium hydroxide, NH4OH, bleaching powder, CaOCl2. So these are the commonly used acids and bases that we are going to use throughout the chapter. Now let's look at some natural sources of acids. These are the naturally occurring acids. The first one is acetic acid. Vinegar has acetic acid. Orange and any citrus fruit, lemon and orange, they both have citric acid. Tamarind has tartaric acid and tomato has oxalic acid. Now how to remember this? The word tomato ends with O. That means the acid present in tomato is oxalic acid, OO. But tamarind has tartaric acid, so don't mix both of them. Next is ant sting and nettle sting, we already talked about. They release methanoic acid and this can be neutralized by the leaves of dock plant, right? So hope you are clear with the basic formulas that we are going to see in the next slide. Now pause this video here. In your notebook, make 3 columns. The first column is the category of the reactions that we are going to talk about. This is column number 1. Second column is the reaction of acids with these categories, and the third is for reactions of bases. So make 3 columns in your notebook and then let's see how all these reactions take place. Done? Great. So the first thing is with metals, how acids and bases, they behave with metals. Both acids and bases release hydrogen gas with metals and a salt is formed. And a short test for hydrogen, presence of hydrogen gases, it burns with a pop sound. If you bring a burning matchstick near hydrogen gas that is being released, it burns with a pop sound. So for example, the reactions of acids and metal are, first one is magnesium H2SO4. If you add a little bit of magnesium to H2SO4, what is going to happen is hydrogen gas is released and a salt is formed. Which salt? MgSO4. So from the reactants, you just take away H2, keep H2 aside and then create the formula for the salt for the leftover ions. Zn plus H2SO4 gives ZnSO4 plus H2. Mg plus HCl gives, again put H2 aside, and what is left out is magnesium and chlorine. So magnesium chloride, MgCl2. Next, aluminium and sulfuric acid, H2SO4. Keep H2 aside, aluminium sulfate, Al2SO4 thrice. Next, iron and HCl. Keep H2 aside, iron and chlorine, FeCl3, ferrous chloride. Now in all these reactions, which gas is released? Hydrogen gas is released. And the most important thing here is, whenever you are writing any chemical reaction, please write a balanced, complete balanced chemical equation. Another thing to note here is, I've shown here just few metals and few acids. But you can get a reaction where you need to write a reaction between any metal and any of the acids. Commonly used acids are only three: HCl, H2SO4, HNO3. Metals could be any of them. So any metal combined with any acid, so any kind of reaction can be there in your questions. Now how do bases react with metals? Again, the reaction basic behavior is similar. Hydrogen gas is released and a salt is formed. Zinc plus NaOH gives sodium zincate, Na2ZnO2. Please learn this reaction. This is very, very important. This is the only reaction given in your NCERT book, and you should remember it is sodium zincate being formed when zinc is added to NaOH and H2 gas is released. Now in place of NaOH, if KOH is given to you in the question, what will be formed? Potassium zincate. So it is K2ZnO2. So similarly, you can create your own formulas also. You can write the reactions if you understand the basic structure of what is going to get created. Next, reaction with carbonates and bicarbonates. Now as the carbonate ion, CO3 2 minus, as you can see, it is going to release carbon dioxide. So for all these reactions, carbon dioxide and water is formed for sure, and then whatever is left out, you combine those ions to create the salt. So how do you write the reactions with acids and carbonates? For example, sodium carbonate plus hydrochloric acid. First write water and CO2, because water and CO2 is anyway formed in all these reactions. So from here, CO2 and water is gone. What is left out is NaNCl. So combine them to make the salt, that is NaCl. Next reaction is sodium bicarbonate plus hydrochloric acid. Again write water and CO2, and what is left out is NaNCl, so that combines to form NaCl. Next is calcium carbonate and hydrochloric acid. Now again CO2 and H2O, write it by the side. What is left is calcium and chloride ion, so it is CaCl2. The name of the salt here is CaCl2. So this is how you can write your own reactions also. If any acid is given to you and any carbonate or bicarbonate is given to you, first write CO2 and H2O and then think of the name of the salt that would get created, right? Now there is one important feature of carbon dioxide gas, that it turns lime water milky. This you must have done in lower grades also. So now the question is, what happens when excess of CO2 is passed through lime water? If a normal quantity of CO2 is passed, it turns lime water milky. We all understand this. So what is actually happening is calcium hydroxide, which is also known as slake lime, this is lime water. So when CO2 is passed through calcium hydroxide or slake lime, we get white precipitate of calcium carbonate and water is left out. So why it turns milky? Because of the formation of calcium carbonate, which is a white insoluble precipitate. Now what happens when excess of CO2 is passed? How do you learn this reaction? What are the products formed in this first reaction is CaCO3 and water. So you write both the things together, CaCO3 and water. Add more CO2, excess of CO2. Add more CO2 to it, and what do you get? Calcium hydrogen carbonate or calcium bicarbonate, CaHCO3 twice. Now when CaH3CO3 twice is formed, the solution again becomes clear. So in the first step, white precipitate of calcium carbonate is formed, but when excess of CO2 is passed, this white precipitate disappears and the solution again becomes clear because of the formation of calcium bicarbonate. So if you get a question on what happens when excess of CO2 is passed through lime water, you have to explain both these steps and write both the reactions. This is a very important question from this part, so please learn both the reactions, write balanced chemical equations and explain that the solution will first turn milky but eventually it will become clear because of the formation of calcium bicarbonate. Now again, a comment here. What are the basic forms of calcium carbonate? Limestone, chalk and marble. Again, you might get this as an MCQ. So what are the three forms? Limestone, chalk and marble. If any fourth option is given to you, that is the odd one out. So these three are the basic forms of calcium carbonate. Now the next is with metal oxides. How do acids and bases behave with metal oxides? As we know, metal oxides are basic. I just told you non-metallic oxides are acidic. They are the cause of acid rain. So metallic oxides are the opposite. They are basic in nature, right? So metallic oxides, because they are basic in nature, they are not going to react with bases. They are going to react with acids. A metallic oxide with acid again gives salt and water. But there is no reaction of metallic oxides with bases. There is no reaction for carbonates and bicarbonates with bases, even though there are reactions, but as per your curriculum, this is not part of class 10 curriculum. Now again, next with non-metallic oxides, because these non-metallic oxides are acidic in nature, they will not show any reaction with acids, but they do react with bases. So if you pick up a non-metallic oxide, that is carbon dioxide for example, and make it react with NaOH, you will get Na2CO3 and water. Now this is important because this is the only reaction given in your textbook, so you should remember bases reacting with non-metallic oxides, that is CO2 gives Na2CO3 and water. Don't skip this reaction, it's important. Now with water, how do acids and bases behave with water? Acids release H plus ions. Bases release OH minus ions, hydroxide ions. So this is the basic behavior of any acid or a base with water. But apart from that, what else is happening when an acid is added or water is added to acid? Now again, this process is called dilution. When you make any acid dilute or you lower down the concentration by adding more water. Here there is a reasoning question why we should not add water to acid when you are diluting an acid. Because it is a highly exothermic reaction and it releases lots of heat that can cause harm. Harm in the sense the vessel that you are using might blast, or it might cause some kinds of burns, because it is extremely exothermic when you try to add water droplets to concentrated acid. So how should the acid be diluted? You take water in a vessel first and then add acid or base drop by drop. So even though this is also exothermic, but the amount of heat liberated will be lesser and it will not cause any harm. So how to dilute any acid or a base? The acid or the base should be added to water but not the opposite. So this is a very important reasoning question on dilution. Next is there is an activity 2.9 given in your NCERT textbook that is related to formation of hydrochloric HCl gas. This is the activity given in your NCERT book. If you look at the setup, you have sodium chloride solution in this test tube and you add drops of H2SO4. Now H2SO4 and sodium chloride NaCl, they react to release HCl gas. How do you test this HCl gas? You bring a blue litmus paper in front of it. If it turns red, that means it is acidic in nature. But what if this gas being released here is made dry and you bring a dry litmus paper in front of it? So you can use a guard tube containing calcium chloride to dry this HCl gas that is being produced, and when you bring the dry litmus paper in front of it, blue litmus paper, it is not going to show any change in color because the gas is also dry and the litmus paper is also dry. So this shows that when any acid or a base is tested with an indicator, it has to be in the aqueous form, only then it will release ions and show you that indicator test. So if you make this blue litmus paper wet and bring it in front of this HCl gas that is being released, then the blue litmus paper will definitely turn red. because now it has water, it is moist, it is wet. So if the litmus paper is wet, it will show you the indicator test, otherwise it will not show you. So this is a very important activity, because at times you get a question on how is HCl gas created in lab. Now you must be wondering what is HCl gas creation and how it is formed in lab. It was nowhere in the chapter. It is about acids and bases, and how come you get a question on formation of HCl gas in the lab. But it is there in one of the activities, and you should always remember. The second thing is, important thing is, indicator tests work only in moist conditions or with water. If the gas is also dry, if the indicator is also dry, it will not show you the test. So NaCl plus H2SO4 gives Na2SO4 and HCl gas is released. The guard tube contains calcium chloride to dry the gas, and it will turn only wet litmus paper to red. It will not turn dry litmus paper to red. Now here the mixing of acid and bases results in decrease in concentration per unit volume. This is called dilution. Please learn the definition as it is. You need to mention concentration of ions per unit volume when you are writing what is dilution. How do bases behave with water? They release OH minus ions. So if any of the bases, NaOH, KOH, MgOH twice, any of the bases is added to water, what is going to happen is the base is going to disintegrate into ions, and OH minus ions are released in water. Water soluble bases are called alkalis. Now the last is, we have already seen how acids and bases, they behave with metals, carbonates, bicarbonates, with metallic oxides, non-metallic oxides, with water. Now what if the acid and the base, they are mixed together? This process is called neutralization. So in a neutralization reaction, the acid and the base, they come together and water is left out with formation of salt. For example, NaOH plus HCl gives NaCl and water, KOH and HCl gives KCl plus water. Right? So we have covered all the reactions of this chapter, everything about acids and bases that you should know. In case you already have the copy of your science notes, I'll suggest take a printout of this page and put it on a wall, put it on the pinboard in front of you, so that you can revise the entire chapter, all the reactions of the entire chapter in one go anytime. So it will be very helpful and very handy for you. So that's it for today. And in the next video, we are going to cover the salts part of this chapter. If you like the video and if you found the video useful, don't forget to click the like button. Share the video with your friends so that they also can get the benefit out of it. Subscribe to Boundless Maths, and don't forget to click the notification icon, bell icon, to get notifications for future videos related to maths and science. Thank you so much for watching. Till then, keep learning, keep growing.